Hi everyone. This is the next in the series of videos that introduces TcOpen framework. In the last video, we have described how to log messages from the PLC to different outputs including Elasticsearch, and we analyzed those logs in Kibana. In this video, we will show how we can create alarms and how objects and components of the framework can provide deep visibility into what is going on with your equipment. The core concepts here are TCO Messenger and TCO Object. TCO Object is a simple yet powerful bit of framework from which most of the blocks in TcOpen derive. It gives you access to the context, logger, alarms, and it provides many capabilities that we will explore today and in the future. We will start with TCO Messenger that provides basic alarm and messaging functions. Okay, so let's get started. We'll start from exactly the same place where we finished last time. So I will just copy this folder that contains our solution and let's rename it to TcOpen 1012 and let's open the solution. Okay, so let me first check if we have any updates on TcOpen. So I will select updates. We are still working with pre-releases and voila, here we have an update on the package TcOpen group. So I will update that. I'm not going to update this serial package because we are working now with a stable version. So let me just update this. Okay, so before we start, we'll create a WPF application to better explain what the TCO object and the messaging is. Okay, so let's create new project. It will be a WPF project. Next, let's call it TcOpen 101.wpf. Next, .NET 5. We should be good with that. And now the first thing we will need to do is to take TcOpen WPF package. So TcOpen group. TcOpen group. Let's browse the packages first. And here we have TcOpen group WPF. Again, the same way we have TcOpen group with all the PLC libraries and the stuff we've seen the last time. The same way we have TcOpen group WPF that integrates all the packages from the TcOpen. Okay, so let's install that into our WPF application. Okay. Accept. So let me just briefly explain one thing. Now we open the NuGet package manager about this TcOpen 101 WPF project. We can do it also this way. We open the NuGet project manager on our solution, and then let me say TcOpen group, browse, include pre-release. We'll get the same list of packages here, but on the right side we will get the list of projects where those packages are installed. So here we see that we have this WPF package in our TcOpen 101 WPF project, and this one is installed in TcOpen PLC connector project. Okay, so let's close NuGet managers, and we will need to make some tweaks to our WPF application. So let's set our WPF application as our startup application. Then we will need to add project reference to our TcOpen PLC connector. In this way we will get access to the PLC twin representation in our WPF project. Okay, so now we'll need to add resources to our WPF application because we are using this material design library for TcOpen in a WPF platform, and we need to add resources in order for that application to work properly. So let's go. I will show you our internal kitchen now for a while. I will go to change log, and I will need to add these namespaces to our app XAML file, and then we will need to add these resources. Okay, so let me do it this way. Resource dictionary, and it will be resource source dictionary dot merge dictionaries. Since we are adding two resources, we need to create merge dictionaries, and with this we added a theme for the material design library and some additional resources from TcOpen. Okay, now we can close this, and let me move some of the stuff we created last time in our console application to WPF applications. So let's first create ViewModel for our main windows. So main window view model. Okay, so we get that. Let's make this public because we will need that. Let's create here a constructor for the view model, and we will just copy this. We copy also this to the constructor of the view model. We will need to bring in the namespaces of TcOpen, PLC, some additional namespaces from TcOpen framework, serial logging, logger configuration. Okay, I will get rid of Elasticsearch. We won't use it in this example, so let me just remove that. We miss this variable, so let me just take it from here, and I will place it here. Okay, so now let me turn this local variable PLC into a property. So it will be property of TcOpen PLC twin controller type. Let's call it PLC. And let's just refactor this to PLC like this. We can make setter private. Okay. So now let's build the WPF solution. You have to keep in mind that when you make changes to your objects, you will need to have those objects or that project built before you can use Designer. So now let me just load the PLC program. Let's run it. Let's open the main window and let's set the data context to the view model we just created. So new main window view model. Here it is. So okay. What just happened is that our view model created the PLC twin. It started the twin controller operations, and since we have here this parameter true, it opened this console, and basically it is running it's retrieving the logs from the previous setup we had. Okay, so now what we could do is that we take let's say text block, we place it here, we set the text property to some variable in the PLC. So let's see something that is actually changing. So start cycle count, and we have to set it to cyclic property. and we see that we get this counter updated. Okay, but this is not what we are going to do, so let me delete this. Instead of that, we will use renderable content control. So let me do it this way. Put grid, and now I will just type renderable content control. We'll need to bring in Vortex namespace. Okay, so, and now we will need to set the data context of this renderable content control, which will be PLC main and simple context. Okay, so what we get here are the variables that this renderable content control was able to render in the UI, but I will not dive into this auto-generating properties of Inkston. It would deserve much larger space, so right now, just to demonstrate how the some features of TcOpen work, I will just say here diagnostics. Okay, let's just so what happened right now, so we said, okay, so we have our TCO context, and when we want to see the diagnostics of that TCO context, then render for us the diagnostics view for that. With this presentation type property, we determine what kind of presentation we want. We could, for instance, say control or we could say control slim, and we would get different representations. So right now we're going to work with diagnostics. Okay, now let's run the application. We get our alarm display up and running, but we don't have any messages at this point, so let's create some. Let's go to our PLC program, and now let's just comment out this logging to not pollute our console window, and let's create a messenger. So you'll need to create an instance of a messenger, TCO core, TCO messenger. Okay. Now, if we do just this, we'll get an error, because most of the objects in TcOpen framework require a specific instantiation. So in this, what we would typically do is we would say this. What this means is that we are telling our object who its parent is. So in this case, it is directly the context. So let's go to our simple context main method, and first thing we will do, we'll set up our messaging. So since we are at the level of context, we could do it directly like this, and we should have environment messaging, and we will set the message digest method. So this is something that is stamping our messages in the shorter form, and to CRC32, and we will also set up the messenger logging methods. Okay, log method on event reason. So in this way, we told our messaging and to our logger when and how the messages are supposed to be logged into context logger. Now let's say messenger. So this is the instance that we just created in the declaration part of our simple context function block, and let's say we want to send an info. So this is an info message. Okay, now for this to work, we will need to run the Vortex builder. Let me load the PLC program. Let's run that. Let's run our application. Okay, so what we can see is that we get our message here. Let's now play around a bit with this messaging. So let's say we would like to say, let's say we would like to report an error. So let's say messenger dot, oops, let's send that to PLC. Okay, we got that message logged. When we update messages, we can see that this messenger has 2 messages inside, but we are displaying only the one with the highest priority. So if we say, oops, if we tell this messenger to send a catastrophic error or critical, let's say critical, okay, which has higher priority than just error, critical message. Okay, so we got the critical message here. And you may notice that we are also logging messages with certain priority. In contrast to logger, we log the messages, as we said earlier, only when the message is arisen. Let's say we will stop calling this. So this means that we won't have any messages in our alarm view. And now when we activate those messages again, we get those messages logged, and when we update messages, we get the same state where we were before. Now let's say we wanted to continuously update the logger, so we can say continuous, and from that moment we would get those messages sent to the logger continuously. I didn't click this auto update because that wouldn't work, so let's make it operational. We'll close the application, and now let's go to our view model, and we will need to add set dispatcher, new TCO core WPF threading dispatcher. So this is something you have to do anytime you use a WPF application. And there's one more thing I would like to change, and because the contrast of the messaging was not that good, so let's say here, let's set that this to blue. Is that so now as we change the message, we should get an update automatically. So you may notice that we have also diagnostics depth, and I guess to explain this is now the time to get to TCO object. I was not completely sure how to approach this topic of TCO object, but instead of explaining abstract concepts, I added some code to our project where I would like to explain what TCO object is and what it does for us. So here we have our folder st1, where we created st001 function block, which is of TCO object. Piston, that also derives from TCO object. And we have a simple state controller where we just move the piston to home position and to work position. Here we initialize inputs and outputs for our piston. Here we just sent a trace message informing about the currently running state number. We created an instance of st001 in our simple context, and to initialize our station, which is a TCO object, we again passed in the context. Now we call the body of the instance of st001 in main method of simple context. I added few things in our WPF application, so let's have a look. Here we have another renderable content control where we display IOGVL in order to be able to control the input signals for the piston. Now let's run the application, and we are going to play a bit with that. So we'll set auto update to true. We will ask also for the trace messages. We are currently running at state 0. This is the messenger that tells us about this state. Now when we have a look at the details, we can see that this message comes from ST001. So here we have the full path to the symbol of our function block. So now in our context we define this piston, which is also of TCO object, and we are at state 0, trying to push the piston to home position. Home position wasn't reached, so let's select this message, and we can see that we got the symbol to the source, which is piston, and move home default task that is reporting warning that the home position sensor wasn't reached yet. Now when we have a component, we can explore deeper what the problems with that component is. So in this case we have a simple pneumatic on cylinder, and we can see what signals that piston uses. I won't go into details how this works. You can have a look in the code. We may come back to that at some other point, but right now set the home sensor to true. Okay, so we see that the state changed from 0 to 10, so we are at this stage and we are trying to move that cylinder to work position. Again, after 10 seconds we did not get that signal, so we got a warning, and let's set now the work position sensor to true. What I wanted to show you here is that we have different objects that are nested into each other, and they are able to report the messages by themselves. Each TCO object implements a messenger that can then report the messaging to this alarm view. As I said earlier, our objects are organized in a hierarchical structure. So here we have a user control that can display any object and its tree structure. So let's get to our diagnostics depth. When we set the diagnostics depth to 1 and we update the messages, we won't get any message because our messenger handler goes only 1 level deep. When we set it to 2, we shouldn't get any message again because we are running up to the level of simple context. When we set the level to 3 and we update messages, we will get this message because this message is of the messenger, which is at 3rd level, and we can display the most important message of that messenger. Now when we go deeper, we should get 1 message more, which is running state. Now at the level of, so we are at this level, ST001, and this object reports the running state. So if we look inside the code, we can see that it is this object that reports running state and its number. When we go deeper, we won't get any additional message because the piston object itself is not reporting a message. Piston itself has additional objects inside, which are TCO tasks, which we will see in some future videos, and so those tasks are reporting messages. So let's go deeper, 1 level deeper, and we should get the warning which says that home sensor wasn't reached yet. In the next video we will explore what the TCO tasks are, and we will get into more details about user action logging, about remote task call, and many other interesting things. If you have any questions, do not hesitate to contact us on GitHub. by creating an issue or by contacting some of the members of Kingston team directly on LinkedIn or on the mail address team@kingston.com. Thank you for watching.